Thanks for joining this fourth annual of the International Day of Women in Statistics and Data Science Conference. With this year's theme, Thriving in Your Environment, we are recording the event, and the videos will be available on the Cooks for Women in Statistics YouTube channel. We kindly ask you to post your questions on the speaker in the Q&A chat. Without further ado, I'm delighted to host this session, 214, Role of Brazilian Women in Statistics, and to introduce the speaker, Vera Tomazella, who was the president of the Brazilian Statistics Association, ABE, for its acronym in Portuguese, and is now a full professor at the Federal University of São Carlos. Vera, it's your time.
Okay. Let me see. Let's see the Jennifer. Jennifer.
Senhora? Senhora?
Você está vendo a minha tela?
Não, professor.
E como eu faço para compartilhar? Eu vou share screen.
Share, sim. A senhora seleciona, aí depois coloca share de novo. Agora foi.
Okay.
Isso, aí.
Good afternoon, good evening. Thank you, Jennifer, for the invitation and to introduce. It's a great pleasure to be here today. So, I'm Vera Tomazella, Departamento de Estatística da Universidade Federal de São Carlos, e today too in Departamento de Estatística da Universidade Federal da Paraíba. Okay? In this presentation, I will talk about survival modeling with Freud and Curie Freud. I will explore foundation, advances, and application in medical data. So, here is the outline of my presentation. First, I will present the basic concept of Freud and Curie-Freud model. After that, I will show how we can integrate both models, Freud and Curie model. After, I will present an example with leukemia dataset and some conclusion. So, let's start with a really very important question. In the context of survival analysis, what do you mean by Freud? The answers. Freud is a hidden factor that makes some people more likely to experience an event, such as death, illness, or system failure before others. Main characteristic of Freud is unobservable and random. Unobservable, not directly measured like age or age, and may involve factors such as environment or genetic effect. Random vary from person to person or group to group. Think about the Freud as the unknown X that explains why some individuals or systems fail sooner than others, even under similar equals conditions. So, another word very important in this topic is unobserved heterogeneity. Unobserved heterogeneity is the hidden variation between individuals that was not or cannot be measured in your study, but that affect the result. In survival model, Freud is the mathematical mechanism that represents unobserved heterogeneity. Think about too early people in the age process. Some age independently, others lose mobility quickly, even with the same clinical variable. There is variability that can be allocated to an observed heterogeneity, such as unmeasured function reserves. So, the idea of Freud model was the Freud first proposed by Volpe and colleagues in 1979. It is used in univariate survival model. After that, Allen and Clayton extended the Cox model to include Pareto term. After, Hogarth investigated theoretical property and distribution of traits, such as gamma, inverse Gaussian, and log normal. So, today, there are many fields to use the Pareto model. For example, epidemiology, time to relapse, survival time with HIV, cancer, and the others. Engineering and reliability, time to failure in system with structural or environmental variability. Actual, science and demography, survival and retirement estimate, medicine, time to events analyze, consider multiple treatment centers, and so on. Today, there are many softwares to help the researchers. For example, Pathna, parametric Pareto model in R. But it's possible to use Stata, SAS, and another. So, the mathematical formulation. The Pareto acts as a multiplicative effect on the baseline hazard. It's possible to consider additive effect too, but in this presentation, I talk about only multiplicative effect. The hazard function and the survival function for individual I is given by this expression. Note that there are no any covariate observed, only no observed covariate in this model. H0t and S0t is baseline hazard and survival function. EVI is the variable Pareto. The interpretation is easy. When VI is greater than 1, more fragile individual, greater risk. When VI less than 1, more resistant individual, lower risk. When VI equal 1, risk equal to baseline. A larger V means a more frail patient with a high risk of experiencing the events sooner. So, but if you have observation covariate X, the hazard function is given by this expression. This is an extension of a Cox model. When VI equal 1, you have a base Cox model. This part is a covariate, observed covariate, okay? Beta is a coefficient for estimate. Okay, to find the unconditional survival function, so you need to integrate the frailty term that is. This is necessary to consider the method of estimate of parameter of model. This GV is a probability density function of the different variable, and this result is denoted the Laplace transform applied of the cumulative hazard function H0t. The problem here, the choice of it probability density function of the different variable, and they chose the parametric form to H0t. Bom, different choices for the Pareto distribution are possible. The parametric specification of the Pareto distribution is a matter of mathematical convenience. So the choice depends on the kind of data set. If the data set is continuous distribution is chosen. In the literature, there are a lot chosen. For example, gamma, positive stable, inverse Gaussian, power variance function, Beban sound, and so on. Discrete distribution too, there are many options too. finite mixture, discrete compound Poisson process, geometric Poisson, negative binomial, zero modified power zero distribution, wiring distribution, and so on. So now I go the specific model, gamma Freight model. Consider gamma distribution with this parameterization, alpha, for variable of Freight. The probability density function is given by this expression, where mean equal 1 and the variance equal 1 over alpha. Note that the alpha control the non-observed heterogeneity this population. When alpha is larger, the variance of Freight is small. When alpha is small, there is a lot of variation between individuals. For this is very, very important is chosen in this model to choose the better the distribution. In this case, gamma is so convenient because the unconditional survival function is given by this expression, easy to obtain in the closed form. For this, gamma is so popular in the literature. Now, I stop a little bit to speak Freight mode. It changed my presentation to talk about Curie Freight mode. After I return to combine both modes. Consider with the fast development of medical treatment, the data in the population generally reveal that a proportion of patients can be cured. In many contexts, for example, cancer, a fraction of individual is cured and will never experience the event. For example, relapse or death because of cancer. Tá? Curie Freight mode split the population in two parts, cured and susceptible. Cured does not experience the event of interest. Susceptible may experience the event of interest. So, several variations in the extent of the Curie Freight mode have been developed along the time. Some approaches, standard mixture model, no-mix model, promotion time, unified approach, defective distribution, zero-inflated Curie rate model, and another approach have studied in this time. So, in this presentation, I will talk about the standard mixture model. The key formula was proposed by Bexley Cage in 1952. The population survival function is given by expression. In this expression, we have two parts. This part represents the population was cured. P0 is the proportion of cured individual. In this part, represents the population is at risk. C0T is a baseline survival function. P0 is between 0.001. The survival function has the following properties. For example, if P0 equals 0, then S-pop T equal S0T. S-pop T equals 0 equal 1. S-pop T is decreasing. When T tends to infinity, S-pop T equal P0. E S-pop T is improper. The plot shows this property. You can see when T tends to infinity, the survival curve stabilizes in the plateau. This plateau is exactly P0, the proportion of cured. You have two parts. This part is proportion of susceptible, and this part is proportion of the no susceptible. Okay? Now, I will go to integrate both methodology, Freight and Cure model. A fraction of the individual is cured, never experienced the event. Among the susceptible group, risk varies due to unobserved heterogeneity. You combine both by introducing the freight term into the susceptible subpopulation. The model formulation is given by expression here. This part is a P0 is the Curie phrase, and this part I introduce the freight term. This is 0T given by VI is a part where I introduce freight. Okay. Now the problem is choosing this part, the individual at risk. This part is constant. I have to estimate. So this plot shows both subpopulation, cured and no cured. It's possible to see in this part, the black line shows the no cure. When the T tend to zero, the survival curve fall to zero. The green line and the red line, you show the low freight and the high freight. It's possible to see that how freight infers in the survival curve. When you ignore the freight in the model, it's possible wrong. Okay? Now I have the conditional survival function given by expression 2. When I replace the survival baseline survival function Laplace transform, I have unconditional survival function. I need to choose the better distribution freight and the better baseline hazard risk to replace this cumulative baseline hazard function. Okay? Now I go to speak about the specific model, standard mixture with gamma freight. I chose gamma with the semi-parametrization, alpha-alpha, and the Laplace transform is replaced in this place. I have two parts, proportion constant, Curie proportion, and this part is include the gamma freight. Now I have the survival population survival population survival given this expression 4, and the density function given by expression 5. Both is improper distribution, survival function and density function improper, because the curve doesn't fall to zero, it's stabilized in the plateau. Okay? Now I will go to choose the baseline risk label. I replacing the H0T for this parametric form. I have simple survival function given by express. I have one model, survival function and density function, totally parametric. I have now to estimate P0, sigma, gamma, and alpha. Tá? Now I use the method likelihood, maximum likelihood to estimate this parameter. So now I will go to present the example in this two application, combine these two methodologies, Freight and Curie Freight. Exactly this 6 and 7 equation, okay? I use the data set studied by Casey and colleague in 1987. This data set had 44 patients and 9 sensors. The event interest of leukemia relapse. The question is, what fraction of patients are potentially cured? And what is the survival rate of choose susceptible? The answer is in this table. I compare the two models, with freight, without freight. You can see P0, the cure proportion, estimated cure proportion is very close, around 20.2%. The alpha with that control the unobserved heterogeneity is given by variance 1 over alpha equal 1.389. This is significant, is very important to control the no observed heterogeneity here. Okay? Now I show this figure. This figure, I compare the freight model without freight together a Kaplan-Meier estimate. The black line shows the Kaplan-Meier curve, and the red and the blue represent another model with freight green, without freight blue. It's possible to note that in the beginning of the period, the freight model follow very, very close of the Kaplan-Meier, the same in the final. This, the both model is very close, but the freight model fit better than without model without freight. Okay, it's possible to see around 1 year the survival curve stabilize around 0.2. This represents the cure ratio of the population. Okay. Now I conclude this presentation. Unobserved heterogeneity is a real issue in survival data. Freight model helps us capture this high variability, while cure model account for individuals who are no longer at risk. When you combine both ideas, we obtain a more realistic and informative picture of the population. In short, include freight and accurate freight allows to tell a more complete and accurate story from our survival data. Thank you.
Thank you, Vera, for your insightful presentation, and thank you everyone who joined us. We hope this concludes this session. We hope you enjoyed the discussion and encourage you to explore the remaining sessions of the conference. If anyone have any questions, can post in the Q&A or in the message when the webinar chat.
Então, eu já parei a compartilhar?
So,
have a question?
no, we don't have any questions, so I guess we can finish this now. Thank you very much for your time, for your presentation. And thank you everyone who joined us.
Thank you so much, Jennifer, for invitation. I love it. Okay.
Bye-bye.